Who's got some ideas how to solve this problem? The plane is at an altitude of 15,000 feet coming in for a landing. The angle of depression from the front or to the front end of a runway is 7 degrees. How far away from the runway is the plane? Well, first and foremost, let's talk about drawing the picture. Okay, so what's the picture look like?
Okay, so I did this way, the right triangle this way, and this side is
So like this?
no, I did it the other way, but I can still do it that way.
Oh yeah, absolutely.
The top is what the angle is. The top angle is the side.
This?
Yeah. You said decreasing.
Mm-hmm.
So it goes down. The plane is right there. And then,
Okay, so you said this was 7?
yeah. No? Well,
You're
because
close.
depressions because there's
Now, let me ask you this. If we're jumping in, I'm gonna jump in really quick here. This angle right here, I'll give you a hint, is not the 7. If the pilot is looking straight forward, what's the pilot's angle that the eyes are at? If the pilot's looking straight forward, let me scoot that out a little bit. Say the plane's right here, the pilot's looking straight out like this. What degree would the eyes be at? It'd be at 0, right? If you're just looking like you're looking straight at me right now, what's the angle that your eyes are at? Are they moving up or down or anything like that? No. If your eyes are looking straight forward, you're at 0. It's like your starting point. So here is your 0 degrees. Now, if the angle of depression, we are always going to have to start, when you're talking about angles of depression or angles of elevation, you start at 0 degrees. So you're going to start at a horizontal of some kind. And this is kind of like a horizontal line, looking straight out. Now, Dante, based off of that, we have 2 different angles here. What do you think now is the angle of depression? Would it be the angle from the 0 degrees down to here, or is it this angle down to here? Yeah, it's the 0 to that angle. So this is something that you might have just kind of forgotten from geometry or from Algebra 1. This is your 7 degrees. Does that make sense? That if I'm the pilot and I'm sitting there and I'm looking straight ahead and I'm looking at the runway, I just go down 7 degrees to look at the front of the runway. And all I did was go down just a little bit to see the front of the runway. And that would be basically the pilot's eyes are looking straight ahead, and then if he's looking at the front of the runway, if it starts here, all he did, the head movement went down 7 degrees. Basically, the pilot's head went down 7 degrees, so his eyes would go from the 0 down to the 7 degrees to see the front of the runway. Does that make sense? Okay. So now, what would this angle be? Now, together with this horizontal and this vertical angle, how many degrees would that angle be?
90?
Yeah, it's a 90-degree angle because it's vertical and it's horizontal. So this angle would be 90 minus 7, which is 83 degrees. Now, that's the hardest part of any type of angle of depression or angle of elevation type of problem is to figure out, all right, how is it actually made? If you're talking about angles of depression or elevation, think of your eyes. Think of looking straight ahead as your starting point, as a zero. And then, do you look up or do you look down? If you're talking about a plane, put yourself in the pilot seat. And if you're looking at the base of the runway, you're looking down 7 degrees. This picture, bam, that's what you're looking for. So you need to use a little bit of imagination to put yourself in position to make either the angle of elevation or depression. Make sense? Okay. We'll practice. Trust me. We'll keep practicing. And we know this is 83 degrees. Now, Dante, help us out. Label. We know the altitude's 15 degrees or 1,500 feet. So where's that? Or 15,000 feet. So it's actually kind of up high. Where's that going to be? It's part of the original triangle. The original triangle is this. Is it going to be, this is the ground. Is it going to be plane to ground? Is it going to be that part to the runway, or is it going to be from plane to runway? If you're talking about altitude of a plane, yeah, the altitude is how high the plane is. So which one's it going to be? So we're at 1,500 feet right there. I can make this a little bit smaller now. Alright, so now I know this is 83 degrees. What am I actually trying to find? I'm trying to find out the distance from where the plane is Now, here's the trick. Is it from the ground to the runway, or is it from the plane to the runway? It's from the plane to the runway. So I'm looking for this guy right there. Now, could you have made an argument that you understood the problem as being from the ground to the runway? Yeah, actually, you could have. You could have come up with that and said, well, that's kind of one way of looking at that problem. And honestly, if you can argue that with me, and by argue I don't mean come up and start yelling at me. By arguing I mean, well, this is how the problem. You know what I'll do? I'll say, I like it. Sounds good. You gave me proof why you did it this way and why you interpreted this. It's one of those problems that's kind of open-ended. But it's not as you might think just because it says, how far away from the runway is the plane? So it kind of implies that there's plane to runway, but there's room for interpretation. So now I have an angle here, this 83-degree angle. And we're in trig mode right now. So what's this side? Is that opposite, adjacent, or hypotenuse?
Adjacent.
Yeah, adjacent. Is it now x? Is that opposite, adjacent, or it's not the adjacent.
Hypotenuse.
It's hypotenuse. So we have an adjacent side that's equal to 1,500, a hypotenuse that's equal to x, and we have an angle that's equal to 83 It's equal to 83 degrees. So, if I think of Katoa. The 7 degrees helped us figure out that the angle inside the right triangle was 83 degrees. So it does help us out tremendously. It just, in the final problem, we're not going to use it. So Which one are we going to use? Are we going to use cosine, sine, or tangent? Which one? Yeah, cosine, because we have an adjacent side and a hypotenuse side. So we're going to use the ka of SOHCAHTOA. So the cosine of what's my angle? 83 degrees is equal to the adjacent over the hypotenuse. What's the adjacent?
1500.
Actually, it's 15,000. I forgot to put a 0. But you're right, 15 with 3 zeros. Now, how do I know the hypotenuse? No, it's an x. So, one thing in math you want to do is you want to do as much algebra as you can before you actually use a calculator. Now, in this case, multiply through by x. So you get x times the cosine of 83 degrees is equal to 1500, or 15,000, excuse me. Divide by cosine. Cosines are gone. I'm left with just x.
But like say, like if I got 4.9
Yeah. All right. So in this problem, what we need to do is we get into a calculator thing here. I'm going to set up a fraction by going control divide. Gives me a fraction. Or even better yet, so we can actually see something a little bit better. We'll give it a second for the navigator to pop up. So you can actually see the keystrokes and everything for it. Alright, I got my calculator, make it as big as I possibly can. Now, if you hit control divide, you get a fraction. And our fraction is going to be 15,000. Control divide. Oh, I'm sorry. Yeah. If you control divide, it gives you a fraction that you can write. Then you type in 15,000. Then you arrow down, and we want the cosine of 83, and we want degrees, don't we?
Wait, what did you press to be cosine?
Trig, right next to 7. Right, but cosine needs an angle. So it's always cosine of an angle. So it's going to be cosine of an 83 degree angle. And we're going to put the degrees after 83. So in order to do that, this guy, if I open up there, I don't have the degree mark, but you guys might. If you choose the pi key next to H, that might work. Over here next to G, G and H are good keys for this because G gives you a bunch of different symbols and it gives you a degree symbol as well. So G and H are two places where you can find degree symbols. So that gives me 83 degrees. And that makes sure that if my calculator is not in degree mode, that my calculator knows that it's taking the measurement of an angle in degrees as opposed to an angle in radians. You hit enter, and you are 123,083 feet away from. This tells me that we're 123,000 feet away, which is pretty far away. Now, how many feet are in a mile?
5,000.
5,001, 5,002. I think it's 5,280. Not 800. It's five. We'll divide. We'll just get a quick estimate. 5,280. Oops. I want to divide that by 5,280. We're 23 miles away. So we're 23 miles out from the runway.
It's not that from me.
Well, you're up 15,000 feet. You might be able to actually see it. And if it's a nice clear day, you can see it. The angle's really small. So the smaller the angle, that means you didn't have to look. It's pretty far away still. If the angle was, like if it was 30-degree angle, you'd be like this. No, there's the runway right down there. But the runway's way out there. But our answer to this question would be I would say approximately 1,000 or 123,000.
I got that about this.
It's a point. There's a 0.6 on there. Okay. So it's right around there, right around 83, 84. Yeah, because you can see the, well, on my calculator I could see it's 0.63572188. My calculator just rounded to the nearest, I don't know what the heck my calculator did. My calculator just, because it was 100, it was 82.63, so it rounded it up to 83. So apparently my calculator on this wants to round.